China's autonomous driving, history, present, and future. Introduction. The autonomous driving industry in China has experienced exponential growth over the past decade, transforming from a nascent sector into a burgeoning field supported by government initiatives and substantial investments from both established automakers and innovative startups. Despite facing technological challenges and public skepticism, the outlook for autonomous vehicles (AVs) in China remains optimistic, fueled by a combination of favorable policies, market demand, and advancements in technology. Historical context. Early developments. The concept of autonomous driving has intrigued researchers and developers for decades. In China, early efforts in AV technology began around the early 2000s, but it wasn't until the 2010s that significant momentum was gained. Government endorsement, particularly through funding and regulatory support, played a crucial role in fostering innovation. Rise of tech giants. By the mid-2010s, major technology firms like Baidu, Alibaba, and Tencent began investing heavily in autonomous driving technology, recognizing the potential for AVs to revolutionize transportation. Baidu launched its Apollo project aimed at developing an open-source platform for AVs, while Didi Chuxing established its autonomous driving division, marking a concerted effort from tech companies to enter the automotive space. Current landscape. Industry growth. As of 2023, China is recognized as a global leader in the autonomous driving sector. According to McKinsey, the country is expected to see widespread deployment of highly autonomous vehicles within the next decade. The shared mobility market, heavily reliant on AV technology, is projected to reach approximately 22.5 trillion renminbi, around $3.52 trillion by 2030, with a compound annual growth rate (CAGR) of 20% to 28%. Government policies. The Chinese government has integrated autonomous driving into its national strategy, explicitly mentioning it in the 14th Five-Year Plan 2021 to 2025. This plan aims to achieve large-scale production of smart vehicles capable of conditional automation by 2025 and highly automated driving capabilities in specific scenarios. The Intelligent Connected Vehicle (ICV) strategy outlines ambitious goals for the development and commercialization of AVs, establishing a regulatory framework to guide the industry. Technological advancements. Despite facing challenges in computing power and sensor development, Chinese companies are making strides in creating advanced driver assistance systems (ADAS) and fully autonomous systems. Firms like Baidu Autox and WeRide have initiated trials for robot access and autonomous buses in various urban settings, with some companies successfully obtaining permits for driverless operations on public roads. Challenges facing the industry. Technological bottlenecks. While progress has been made, significant technological hurdles remain. China is still catching up in several key areas, including high-precision mapping, real-time data processing, and sensor technology. The global semiconductor shortage has further complicated matters affecting production schedules and the rollout of AV technologies. Public perception. Public skepticism about the safety and reliability of AVs poses a significant challenge. High-profile accidents involving autonomous vehicles have drawn media scrutiny and raised concerns among consumers. Building public trust through transparency, rigorous testing, and effective communication will be crucial for the industry's acceptance. Regulatory environment. The regulatory landscape for AVs in China is evolving but remains somewhat fragmented. While the government has issued guidelines and standards for the testing and operation of autonomous vehicles, the lack of comprehensive nationwide regulations can create uncertainty for developers and investors. Future prospects. Market potential. The future of autonomous driving in China is promising. By 2040, it is estimated that AVs will account for 66% of passenger kilometers traveled, generating approximately $1.1 trillion in mobility services revenue. The market for AVs is set to grow as technology improves and consumer acceptance rises. Investment opportunities. China's autonomous driving sector is attracting substantial investment from both domestic and foreign entities. Various sectors related to AV technology, such as hardware development, software engineering, and data analytics, are open for investment. The government actively encourages foreign investment to foster innovation and collaboration. International expansion. Chinese autonomous driving companies are also looking beyond domestic markets. Startups like Autox and Pony.ai are conducting tests in the United States and other countries, signaling their ambitions to become global players in the AV sector. Conclusion. China's autonomous driving industry, fueled by a combination of government support, technological advancements, and a growing market for mobility services, is poised for significant growth in the coming years. While challenges remain, the trajectory suggests a future where AVs play a critical role in transforming transportation, enhancing efficiency, and addressing urban mobility challenges. As the industry matures, it will likely reshape the way people and goods move across the country, reflecting China's broader ambitions to lead in technological innovation. 1. Historical context. The rapid development of China's self-driving car industry within the past decade has transformed it from a niche sector to a prominent area of government and industrial focus. The optimism surrounding this industry has persisted despite technological hurdles and public skepticism. 2. Market potential. China's self-driving industry is predicted to grow significantly, with expectations of achieving a shared mobility market valuation of approximately 22.5 trillion renminbi, around $3.52 trillion by 2030. This indicates a strong belief in the transformative potential of autonomous vehicles, particularly in the shared mobility segment, such as robot access and autonomous buses. 3. Government support. The Chinese government has integrated autonomous driving technology into its national strategy, specifically highlighting it in the 14th Five-Year Plan. This support is pivotal for the growth of the industry, as it reflects a commitment to fostering innovation and competitive advantage in autonomous driving technologies. 4. Technological challenges. Despite the enthusiasm, significant technological challenges remain, particularly in computation and sensor technology. While the U.S. was historically the leader in this space, China's favorable regulatory environment and rapid technological development are enabling it to potentially overtake the U.S. in the coming years. 5. Future projections. Forecasts suggest that by 2040, autonomous vehicles may account for 66% of passenger kilometers, generating up to $1.1 trillion in revenue from mobility services. This aligns with trends indicating a shift from traditional vehicle ownership to service-oriented models, potentially revolutionizing how transportation is perceived and utilized. 6. Public sentiment. While Chinese consumers generally embrace new technologies, there remains a significant concern regarding the safety of autonomous vehicles. Public trust is a critical barrier to widespread adoption, necessitating robust government oversight and transparent communication from manufacturers. 7. Investment opportunities. The Chinese government is encouraging foreign investment in various segments of the autonomous driving industry, including hardware development, R&D, and the manufacturing of components essential for autonomous vehicles. This creates a unique opportunity for foreign investors to collaborate in China's burgeoning tech landscape. 8. Regulatory landscape. China has opted for a strategy of innovate now, regulate later, allowing companies greater freedom to develop and test autonomous technologies. This approach could potentially provide Chinese firms an edge over competitors in more heavily regulated markets. 9. Challenges of global competition. The global semiconductor shortage, exacerbated by the U.S.-China trade tensions, poses a significant risk to the autonomous vehicle sector. China's reliance on imported technology for critical components like auto chips highlights vulnerabilities within its autonomous vehicle supply chain. 10. Long-term vision. The overarching narrative is one of cautious optimism. While the path to fully autonomous vehicles is fraught with obstacles, the potential rewards are immense. The government's commitment to developing this industry, combined with a robust domestic market and increasing international collaboration, positions China as a formidable player in the future of mobility. In summary, the interplay of government support, technological challenges, market potential, and public perception creates a complex landscape for China's autonomous driving industry, which is poised for significant evolution in the coming years. Important content overlooked in reports on China's autonomous driving industry. 1. Long-term vision versus immediate challenges. While many reports highlight the optimistic projections for the autonomous driving industry in China, such as McKinsey's forecast that AV's autonomous vehicles could account for 66% of passenger kilometers by 2040, what is often overlooked is the significant gap between this long-term vision and the immediate technological and infrastructural challenges. Key challenges include the need for better computing platforms, advanced sensor technologies, and the development of a regulatory framework that balances innovation with safety. This disconnect is significant because it emphasizes that despite the ambitious goals, the path to achieving them is fraught with uncertainty and potential delays. 2. Government policies and their implications. The Chinese government's active role in promoting the autonomous driving industry, particularly through its 14th Five-Year Plan, is frequently mentioned but not deeply analyzed. The implications of these policies, such as the emphasis on vehicle-road collaboration and smart transportation systems, indicate a strategic shift towards integrating autonomous vehicles into a broader smart city infrastructure. This integration is significant because it aligns with China's goals of reducing urban congestion and pollution, and it may create a more favorable environment for AVs than in other countries where regulatory frameworks are less cohesive. 3. Public perception and its impact on adoption. The public's perception of autonomous driving safety is another critical aspect that is often glossed over. While many reports indicate that Chinese consumers are generally more accepting of new technologies, the underlying concerns about safety and trust in AVs can significantly impact adoption rates. The potential for accidents or malfunctions and the media's portrayal of these incidents can create public backlash, delaying the acceptance and integration of AVs into everyday life. Understanding public sentiment is vital for companies to develop effective communication strategies that address these fears, ultimately influencing market growth. 4. Investment trends and market dynamics. While investment in the autonomous driving sector is highlighted, the nuances of these investments, such as the differentiation between domestic and foreign companies and how this affects competition, are often overlooked. Chinese technology giants like Baidu, Alibaba, and Tencent are not just participants, they are shaping the industry landscape. Their deep pockets and technological expertise create a competitive environment that foreign companies may find challenging to navigate. This dynamic is significant as it shapes the innovation landscape and the global competitiveness of the autonomous driving sector. 5. Integration of emerging technologies. Reports tend to focus on the autonomous driving technology itself while overlooking the integration of other emerging technologies such as 5G and artificial intelligence, which are crucial for the success of AVs. The role of 5G in enabling real-time data transmission and reducing the cost of onboard computing is a significant factor that could accelerate the development and deployment of AVs. This integration is crucial because it not only enhances the functionality of AVs but also positions them as part of a broader ecosystem of smart transportation solutions. 6. Impact of global supply chain issues. The ongoing global chip shortage and its implications for the autonomous driving industry are often mentioned but not explored in depth. The reliance on imported technology for key components such as semiconductors and sensors is a significant vulnerability for China's AV sector. The geopolitical tensions, especially with the U.S., add another layer of complexity to supply chain stability. This situation underscores the need for China to bolster its domestic manufacturing capabilities in critical technology areas to ensure the long-term viability of its autonomous driving ambitions. 7. Regulatory environment evolution. The reports often touch on the regulatory environment but frequently miss how rapidly it is evolving. The innovate now, regulate later approach has allowed for faster technological development, but as the industry matures, the transition to a more structured regulatory framework will be necessary. This transition is significant because it may determine how quickly companies can adapt and innovate, impacting their competitiveness in both domestic and international markets. 8. Diversity of applications beyond personal vehicles. Many discussions around autonomous driving focus primarily on personal vehicles such as robot access. However, the diversity of applications, including freight transport, last-mile delivery, and public transportation, represents a broader market opportunity that is frequently underexplored. This diversity is significant as it suggests that the potential for autonomous technology extends far beyond consumer vehicles, impacting logistics, urban planning, and even emergency services. 9. Cultural attitudes toward AI and automation. The cultural context surrounding technology adoption in China, particularly the acceptance of AI and automation, is a crucial aspect that may be overlooked. The Chinese population's willingness to embrace technology influenced by government narratives and societal trends can significantly impact the success of autonomous driving initiatives. This cultural backdrop is significant as it shapes consumer behavior and influences the strategies companies must employ to gain market traction. 10. Potential environmental impact. The environmental implications of deploying autonomous vehicles, particularly in relation to urban air quality and traffic congestion, are often mentioned but not analyzed in depth. The potential for AVs to contribute to reduced emissions and improved urban mobility presents a significant opportunity for addressing environmental challenges in rapidly urbanizing areas. This aspect is critical as it aligns with global sustainability goals and could bolster government and public support for the industry. Conclusion. In summary, while the reports on China's autonomous driving industry provide valuable insights, they often overlook critical nuances that could provide a more comprehensive understanding of the sector's challenges and opportunities. Recognizing the significance of these overlooked aspects, ranging from public perception and investment dynamics to regulatory evolution and cultural context, can better inform stakeholders and investors as they navigate this rapidly evolving landscape. Understanding these dimensions will be essential to harnessing the full potential of autonomous driving technology in China, ensuring that it not only meets market demands but also aligns with broader societal and economic goals. 1. Government support and strategic importance. The Chinese government has recognized the significance of autonomous vehicles in its economic and technological strategy, including it in the 14th Five-Year Plan. This strategic endorsement is crucial as it not only provides a regulatory framework but also incentivizes investment and development in the sector. The goal is to achieve mass production of smart vehicles by 2025 and widespread deployment by 2030, which highlights the government's commitment to positioning China as a global leader in autonomous driving technology. 2. Market potential and economic impact. China's self-driving car market is projected to reach approximately 22.5 trillion renminbi, around $3.52 trillion by 2030, with a compounded annual growth rate of 20 to 28%. This statistic underscores the vast economic potential of autonomous vehicles in transforming the transportation landscape, particularly through the growth of mobility services like robot access and autonomous buses. Such services are expected to account for a significant portion of transportation revenue, estimated at $1.1 trillion from mobility services alone by 2040. 3. Technological challenges and competitive landscape. Despite the optimistic forecasts, the industry faces significant technological challenges, including the need for advancements in computing platforms, sensors, and system integration. While China is catching up to global leaders like the US, it still lags in several critical areas. Additionally, the competitive landscape is intensifying as both domestic companies such as Baidu and Didi Chuxing and international players invest heavily in autonomous driving technology, highlighting the importance of addressing these technological hurdles to maintain a competitive edge. For public perception and regulatory environment, public trust and safety concerns remain significant barriers to the widespread adoption of autonomous vehicles in China. While consumers show a general openness to new technology, there are lingering doubts about the safety and reliability of self-driving cars. Strengthening regulatory frameworks and ensuring transparency in data collection and safety measures will be vital in addressing these concerns. Recent regulations, including data security laws and standards for autonomous vehicle testing, are steps towards building consumer confidence in this emerging technology. 1. The development of the American automobile industry 1910s to 1930s. The American automobile industry underwent a transformative phase during the early 20th century, particularly marked by the introduction of assembly line production by Henry Ford. This innovation drastically reduced the cost of car manufacturing, making automobiles accessible to the general public. The Model T, introduced in 1908, became a symbol of this era as it revolutionized personal transportation and spurred economic growth. The industry's rapid expansion also led to significant changes in urban planning, infrastructure development, and consumer culture in the United States. Paralleling the current advancements in China's self-driving vehicle sector, which is also reshaping transportation norms and urban landscapes. 2. The adoption of railroads in 19th century Britain. The rise of railroads in Britain during the 19th century is a historical case that reflects a similar transformative journey. Railroads revolutionized transportation and logistics, enabling faster movement of goods and people across the country. This innovation was supported by government policies, investments in infrastructure, and public enthusiasm similar to China's current push for autonomous vehicles. Just as the railroad enabled new economic opportunities in urbanization, autonomous vehicles promise to change the fabric of society by introducing new mobility services, reshaping urban environments, and addressing labor market shifts. 3. The launch of the space race 1950s-1975. The space race between the United States and the Soviet Union represents a historical instance of intense competition and technological innovation driven by national ambition. The race to develop space technology saw significant investments in research and development, resulting in groundbreaking advancements in various fields. The launch of Sputnik in 1957 marked the beginning of this era, leading to rapid progress in aerospace technology and satellite communications. Similarly, China's ambitions in the autonomous driving sector reflect a strategic national interest in leading global technology markets, where the competition for advancements in AI and automation is reminiscent of the technological race during the space race era. Future outlook: predictions for China's autonomous driving industry. The autonomous driving industry in China has experienced rapid growth over the past decade, supported by government policies and investments. As we look toward the future, several key predictions emerge regarding the evolution of this industry, its challenges, and its potential impact on society and the economy. 1. Technological advancements and adoption. By 2030, we anticipate significant improvements in the technology supporting autonomous vehicles (AVs). Enhanced artificial intelligence (AI) algorithms, advanced sensors, and high-definition mapping will likely lead to more reliable and safer self-driving systems. By 2040, McKinsey predicts that AVs could account for up to 66% of passenger kilometers traveled in China, translating into substantial revenue from mobility services estimated at $1.1 trillion. 2. Market growth and economic impact. The shared mobility market in China is projected to reach approximately 22.5 trillion renminbi, around $3.52 trillion by 2030. Driven by the demand for robotaxi services and autonomous buses. This market is expected to grow at an annual rate of 20% to 28%. The transition from private vehicle ownership to shared mobility services will be a defining feature, with many consumers opting for on-demand transportation solutions rather than owning personal vehicles. 3. Government support and regulatory framework. The Chinese government will continue to play a crucial role in the development of autonomous driving technologies. Policies outlined in the 14th Five-Year Plan emphasize the importance of smart transportation and autonomous vehicles as strategic areas for economic growth. The establishment of a regulatory framework that supports AV testing and deployment is expected to evolve, addressing safety, liability, and data privacy concerns. 4. International competition and collaboration. China is poised to become a global leader in the autonomous driving sector, competing with the United States and Europe. As Chinese companies expand their reach internationally, there will be increased collaboration between domestic firms and foreign entities on technology development, standardization, and regulatory practices. This collaboration is crucial for addressing the complex challenges of developing AVs suitable for diverse driving conditions and regulatory environments. 5. Public perception and trust. Despite the technological advancements, public acceptance remains a critical hurdle. Concerns about safety and reliability will continue to shape consumer attitudes toward AVs. To foster trust, companies will need to engage in transparent communication, demonstrate safety through rigorous testing, and work closely with government agencies to implement effective regulatory measures. Public opinion can be further enhanced through successful pilot projects and positive media coverage. 6. Challenges in infrastructure and data management. The integration of AVs into existing urban infrastructure presents various challenges. Investments in smart infrastructure, including communication networks and traffic management systems, will be necessary to support the widespread adoption of AVs. Additionally, as AVs rely heavily on data, managing data privacy and security will become increasingly important. Stricter regulations regarding data management will be essential to protect user information and ensure compliance with national standards. 7. Environmental and societal impacts. The rise of autonomous driving technology is expected to yield environmental benefits, including reduced emissions from optimized driving patterns and a decrease in traffic congestion. However, it may also lead to societal challenges such as job displacement in driving professions. The government and industry stakeholders will need to proactively address these concerns through retraining programs and policies that facilitate a smooth transition for affected workers. 8. Investment opportunities and economic shifts. As the AV industry matures, investment opportunities will expand across various sectors, including software development, sensor manufacturing, and infrastructure enhancement. Companies engaged in research and development of autonomous technologies will attract significant capital, fostering innovation and growth. The economic landscape will shift, with mobility services becoming a prominent sector, challenging traditional automotive sales paradigms. Conclusion: China's autonomous driving industry is on the brink of transformative growth, driven by technological advancements, government support, and changing consumer behaviors. While challenges remain, particularly regarding public acceptance, regulatory frameworks, and infrastructure development, the potential rewards are substantial. By 2040, the landscape of transportation in China may be radically different, characterized by widespread adoption of autonomous vehicles and a shift toward a service-oriented mobility ecosystem. The path forward will require collaboration among stakeholders, a commitment to safety, and ongoing innovation to realize the full potential of this promising industry.